Hey everybody, this is Larry. This is day 21st of the Leetcode October Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Oh yeah, I always talk about celebrating your victories. Sometimes they could be big, sometimes they could be a little bit smaller, but just uh, do something to kind of celebrate your victories. And in the spirit of that, I do actually have, trying to keep positive vibes and stuff like that. So join me on Discord if y'all want to share your stories as well. But I'm going to share mine, which is that I guess it's been a couple of days now. I just kind of forgotten about it, which is that almost made top six or top five, but I was six on the recent contest by about 3 seconds. If I was 3 seconds faster, I would not have to click into it. I could have just seen myself here. Anyway, I just figure I kind of celebrate that a little bit and hope y'all celebrate your victories with me. Hopefully on Discord and people just kind of hang out. Anyway, today's problem is insert, delete, get random, 01. Let's see what that actually means. Why do I have a... Oh, okay. Anyway, so insert, delete, get random, 01. I think they, at some point, Leetcode just stopped caring about naming problems clearly. This isn't even a title anymore. It's just like, okay, let's just do these things. They could call it randomized set. Maybe it would have been okay. Anyway, okay, that's enough. I mean, we could keep making fun of it and let me know about your best jokes in the comments. But anyway, okay, so implement. Let's actually read the problem. I also, for the newer viewers, for some reason you choose this video to be one of my new viewers, then I usually start these live. So if it's a little bit slow, fast forward a little bit, and I try to inject whatever I know about these things. Okay, let's actually read the problem. So you have the constructor, insert, checks to see if it's in the thing, remove to see if it's in the thing as well, but also removes, get random, returns a random element from the current set. Okay, works an average over one complexity. Okay, let's look at some constraints. So I mean, I think what so one thing that I'm trying to avoid doing is not use libraries, because if actually, let me think. Even if I use a library, can I get this in a good case? Don't know actually. Is it so can we keep on calling random, or and the big thing is also average is O of 1 instead of actually O of 1, but I don't know that there's anything that tricky about it. Because okay, so the insert and the remove we could put in the hash table. Yeah, okay. I mean, I think we can just use a lot of arrays, and that should be okay. The only thing that I'm trying to think is if you remove a lot, you may have to kind of do some math. So I think this is actually a good proxy for, if you think about how it's structured, a lot of the proofs that I'm going to go is kind of a corollary with hash tables. And what I mean by that, hopefully you'll see later. So I may do a little bit of hand waviness, to be honest, where I would just say this is exactly the analysis as hash table. And that allowed me to kind of leave the exercise at home kind of thing without doing the math. But okay, but I think, so okay, just to go over my thought process from beginning to end so that you can follow, or maybe kind of at least see how I solve it with respect to the thought process instead of just the coding. I'm kind of to go back a little bit, because I think I went through it in my head without talking about it, and it was very quick. But the first idea that I had, okay, so the first thing I wanted to say was that I was like, okay, I don't want to use any libraries if there's a library to support it, because if I use a library, it's a little bit awkward and so forth, right? Yeah. And then the second thing is, okay, let's say I have Um, mm, yeah, let's say I have an array of things, right? Like, let's say there's a sorry, I was just thinking about how I was thinking about. Let's say I have an array of things, and then insert would insert something to that array. Remove will so that insert something to an array at the end, presumably. In O of one is easy, but remove is tricky. So to get removed to O of one, so now I'm thinking about two functions, right? Insert and remove. If I change remove to be O of one, that would require just like a lookup thing, right? And then I remove it. But then that means that if we choose to do get random, in that case, get random might not yield us, like for example, my idea was that, okay, let's say we have some lookup thing. Let's say I have some lookup thing where I have, I added 3, 2, 5. I don't know if it's unique. So let's just say 3, 2, 7, and then we choose one number random from it, right? And then later we remove, say, 3. I'm gonna leave it blank for now. But so that was gonna be my strategy of just leaving it blank. And then what does random mean, right? Random, you can say that there's a probability of getting a none, and then you could reflip. Well, I thought, okay, if you reflip, that's not good enough, right? Because you can imagine, like, we have 100 numbers and then we remove 99 of them. 90, whatever, right? Like, we remove a lot of them. Then if you keep on reflipping, it only has 1 in 100 chance of getting it right, which is, you're gonna run into some complexity issue, right? So that's no good either. No bueno. So then I thought, okay, how do I amortize this out? Well, the short answer to that is kind of, I hinted it a little bit earlier, which is with hash tables, right? Or the analysis that you might learn if you learned hash tables, which is that, okay, if you double, if you double on, it's the same thing with hash tables in the sense that if you double, every time you add an element and you run out of space, you double, then you go, that's good. I'm not gonna go over the proof that much, but you can amortize each element's insertion into O of one, right? And also if you go below, I think a certain ratio, is that half? I think it's half, or maybe it could be a little bit lower. But if it goes below half, no, that doesn't make sense. Half would be, half of the original, so I guess 1/4. If it goes too sparse, then you also resize it to be smaller, right? So that's basically the idea. I think it's either I guess the 1/4 of the new table or 1/3 of the new table. We could play around with some math to do so that the amortization makes sense, but that's basically the idea that I think I would play with, right? I don't know if this is the intended answer, but that's an idea that I know would be one, because and the proof of each of those components is because it is similar to hash tables analysis, right? Of growing double and removing double. And then the tricky thing is, how do you add things in a place such that how do you add things in a way such that you keep everything all of one? And I think that's part of the and removing and stuff like that. That's kind of interesting. So we'll play around these ideas all together. But that's basically how I evolved there. I go, okay, let me try to satisfy one function at a time, and then try to incorporate other functions, and then put it all together one at a time. Let's start hacking. I think I'm ready to kind of start hacking now. So let's just say, let's just say numbers is equal to no element, and then we can implement this incrementally. And we have to have some set elements for here. So okay. So let's just say we have a lookup. It's a hash table. And we might need more things, but let's start with this and then kind of think about it, implementing one by one. So insert, what we want is self.numbers. We have to, okay. Oops. Let's, okay, let's start with one none element maybe. How do I want to phrase it? because I think insert you can also just append, but I don't. Append is fine. So you don't even need to do the doubling, perhaps, because it is handled for you. If I think removing when it gets too low will make it easier in general. No, that's not true. Actually, no, I think there's another way. Okay, so I think the way that we talked about is true, but I don't think we need to do it that way. There's actually a better way. Okay. And it's easy to explain too, so I'm going to do it that way, and then we'll see. So yeah, so okay, wow, that's actually a cool solution now that I think about it. So you don't see me, at least on the daily problems, you don't see me have these kind of insights often because, well, one is I've seen enough of these, but two is that they don't give you too hard of problems generally, knock on wood. But yeah, so now here we can have lookup, and then self.lookup of, wait, I assume that these things are, I want to see if these things are unique. Return true if the item is not present. Is there any sense of uniqueness? Like, can you insert the same number multiple times? Oh, I actually misread. Oh, I didn't misread, but I just read it again. Now I see. So insert to it if it's not present. Okay, so we got it. So yeah, so then we can do something like this is equal to the length of self.numbers, right? Is that right, or am I off by one? Yeah, I'm off by one. So let's actually do this before. Or you can just do it like this way. It doesn't really matter. Okay, let's do it this way. And then on remove, let's get index as equal to self.lookup of value. Oh, I have to also do some validation, sorry. So if self.lookup, or if the value is already in self.lookup, we return false, and then we return true for success. There's double negative here maybe, so that's why I'm gonna true if the item is not present. Okay. I mean, they could have also just said it was successful, so yeah. Okay, so if val is in self.lookup or not in it, we return false. Otherwise, we look at the index. So what I was going to do was some magical thing with hash table, like I said, with expanding and then shrinking. But actually, what we can do is we look up the index. We remove. Whoops. We remove this index per se. Like, for example, we can say this is equals to none, and the naive thing to do would be just remove that element and everything shrinks down, but that's going to be O of n. So actually what we can do, however, is let's just say we set it to none, right, and then return true. Well, that's good, but like I said earlier, that is going to create gaps, right? So how do we not have gaps? So I did talk about shrinking, but actually I just had that insight, and you kind of see me go, oh, that's cute. Which is that, okay, you can actually just take the last element and then move it to this bucket, if that makes sense. And the reason is just because, then they're buckets, or they're in, because the actual element, the positions in the elements don't matter as long as we keep track of it, right? So then now here we can go, okay, so this is the last element. Oh no, that's not true. This is n minus 1, so this is just this, but I was confused. So basically it sets it to the last element, and then we want to remove the last element. And that's pretty much it, except for we have to update the lookup table. But that's pretty much it after that. So lookup table of value is equal to index. Oh no, sorry. The lookup value of the new value is the lookup index. So yeah, so it's just this thing. And I think now we should be good. And here, I don't think I have to do any proofs now. You could see that here on push is O of 1 and on pop is O of 1. And on random becomes easy because it's just a random number from numbers. And I actually forget I think there's a random element thing from Python that I always forget how to pick random. There are a couple of Or like I just don't remember the libraries because there's like int and or get int or something like that. So I just never remember. Now random.choice seems to be good. Okay, so let's just do random.choice of self.numbers. In this case, I don't really worry about using the library because your point is not, I mean, you can just get a random number, mod it or whatever if you like, but that's not the point of this problem anyway. I wouldn't read that as the point, so I'm okay with this. Let's actually run the test case real quick, and hopefully I don't have any silly mistakes, but this feels good, so yeah. Let's give it a, am I good? Yeah, I mean, so the reason why I didn't really look at the constraints anymore is that you know, this is O of 1 because we just append, which is O of 1, and then we put something in the lookup table. Yeah, okay, I mean, we're going to treat it as the hash table complexity, so it's going to be O of 1. But, you know, do your own math if you want to think about it more. This is also O of 1 because we just pop to remove and also update the lookup table. Oh, I missed one thing, actually, which is that we want to delete the lookup table's entry for this value. So actually that would have been a bug because this would have returned false or something like that, or this might return true without us doing this. So yeah, so this is actually a good catch now that I looked at it. Whoopsie daisies. But yeah, let's run it real quick. And then here, this is O of 1. Wait, is this O of 1? Actually, I don't know. Huh. Actually, I don't know with Python's random choice performance, because this could be O of N. Like, it depends on how they implement it. It could be O of N or O of 1. And I actually don't know if I actually don't know how they implement this. So maybe I'm wrong on this one. Maybe you do just need to pick a random number instead. Okay, I can't find it off the bat, and I don't want to spend too much time having you look at me look at Google. So I'll do the way that I know to be true, right? How do I get a number? Python get random int. Randint. Randint. Hang on, let me double check the syntax. Because I know there's also randint with parameters. I don't have to do the mod thing myself. But a rand range. Is it deprecated? No? Okay. So actually, yeah, let me change this to random.rand range. Is that right? Huh. Yeah, okay. So rand range of from 0 to, I guess 0 is implied, I think. So then we just do length of, is it inclusive? Actually, these are things that I don't do enough. Is it inclusive? Man, it is not super clear. Dong dong dong. And range inclusive. Sorry, friends, give me a second. I am doing these, you know, live, but okay, so it's not inclusive, just like range, which I guess makes sense. So we want this plus 1. Oh wait, no, this is right then, right? If there's 1, then it goes, yeah, okay. So this is non-inclusive on the end side. So yeah, so then we can return self.numbers of this array, right? So let's run it real quick. But yeah, this I know would be O of 1, right? So I'm happy there versus O of N. So yeah, so that's good. Wow, what a possible slip up on, because on a sequence it's not clear. For me anyway. Maybe it is constant, but now I know for sure it's constant. Or you know, in the number of bits, depending on how you want to do randomization. But anyway, cool. Let's give it a submit. And I got it accepted a year ago. seems like every problem I got in a year ago. Oh, did I do something wrong? Got a wrong answer. That's a little bit odd. Honestly, did not expect that. Let's see. So we remove, insert, get random, remove, insert. Oh, that is a silly mistake by me. Maybe? Remove doesn't do anything. So, oh, because this assumes that after the removal, there's at least one element afterwards. But I guess that's not true. I misread part of the description because it said that there'll be one element in the data structure when GetRandom is returned, which is true, but it's not always true because you can remove and then insert and then GetRandom later, right? So okay, wow, that is subtle. But okay, so that means that we have to just choose. Okay, so this is the current index. We can do this, have that lookup immediately, and then we also No, I mean, I guess this code is correct if we delete afterwards, because then this would be itself, however awkward it feels. So yeah, okay, so maybe this works. Let's give this a quick spin. Okay, so this looks better. Let's give it a submit. Wow, what a silly mistake on that one. Maybe there's another one. Okay, that's good. I actually don't know how I did it last time because the timing is so much slower this time. And I actually have no recollection of this problem, to be frank. I don't even know if it's a daily problem or not, but apparently I had a wrong answer. So I want to take a quick look to see where I can learn. But yeah, but that said, you know, this is O of 1, O of 1, O of 1. So we should be very Gucci. Very good. But running time is kind of dubious though. What did I do last time? Oh, I did use random.choice though. I don't know. But it seems like I did exactly the same thing, pretty much. I just didn't really remember it. I wonder if I did the thing with the doubling last time. Do I have a video on this? I don't know. But I did the ordering correct this time. Though I wonder if I just was a little bit luckier because I don't know if I would have remembered this edge case. But it seems like the code is mostly the same, so they might have just added more test cases or something like that. But yeah, that's all I have for this one. It's either that or this thing is really slow for some reason. But yeah, I don't know. Anyway, that's all I have for this one. Stuff's still good. Let me know what you think. Apparently there's a duplicate version, which I think is just the same implementation, to be frank. Except for that we keep things in a list instead of in an array. But yeah, that's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. Have a great rest of the week. I'm going to take a nap. I'll see you later, and bye-bye.